Hello everyone. Today we are going to discuss about the hybridization in sulfur and ppi-dpi interaction in different sulfur compounds. Sulfur has total 16 electrons like electronic configuration shows 1s2, 2s2, 2p6, 3s2 and 3p4. Some compounds of sulfur like sulfides, sulfones, SO3, some compounds show this type of ppi and dpi interactions. These type of interactions are can be represented through hybridization. So we can discuss hybridization. I can draw the shapes of these compounds, hybrid orbitals, and then show the ppi and dpi interactions in this type of compounds. First we discuss about this compound. So we draw like this. So first we see the hybridization. There is sulfur. Sulfur has double bond with oxygen and there are two methyl groups attached with the sulfur. So also this compound has one lone pair. So how we write the electronic configuration of this? In this case, if we draw the hybridization of this compound, so this is 3s, 3p and 3d orbital. 3s has two electrons, so here 2, 3p has 4, 1, 2, 3 and this one is 4, fourth one. So now in this case the electron from 3p orbital move to 3d. So now electronic configuration is like this: 1, 1, 1. uh, so one electron here in the 3d orbital. So now 2 electron in 3s, 3 electron in 3p and 1 electron in 3d. So in this example, in this case, in this sulfur compound, sulfur shows sp3 hybridization, which have one lone pair of electron that shown. The 3s has paired electron, so this is the paired electron. So now we draw the hybridized orbitals and show the ppi and dpi interactions. In the case of oxygen, oxygen has 8 electrons: 1s, 2s, 2p, 4. So 2s and 2s has 2 electrons, 1, 2, 3 and the fourth one. It shows sp2 hybridization, sp2, and this one electron pair here form a pi bond, and this one electron in the d also form a pi bond. So now we draw the hybrid orbital. First we draw the shape of sulfur. Sulfur shows sp3 hybridization in this case, so we draw sp3 shape, tetrahedral shape. This like this. This is the tetrahedral in the case of sulfur. So now we draw methyl group. This carbon has single bond, so sp3 hybridization. This also have other methyl group, the second one, and here third orbital. Now here is the lone pair. Which one? This one. This one here. Now we draw the oxygen. Oxygen has double bond with sulfur, so it shows sp2 hybridization. So sp2 hybridization has shape like this. So this pi bond of oxygen, because double bond has one pi bond and one sigma bond. And here now we draw the 3D orbital of sulfur, which form p-pi and d-pi bond. The p-pi is for oxygen and d-pi is for sulfur. The d orbital of sulfur form pi bond with the p orbital of oxygen. This is d-pi and this is p-pi. The p orbital of oxygen form pi bond with the d orbital of sulfur. These type of interactions are present in some sulfur compounds that is known as p-pi-d-pi interactions and or p-pi-d-pi bonding. So here are the two lone pairs, this and this, two lone pairs of oxygen. Here is the hydrogens. In this way we draw the shape of dimethyl sulfoxide. We can complete the shape with electrons. This is carbon, this is lone pair, which one lone pair? This lone pair, and these two are the lone pair of oxygen. So this is the shape of this compound which shows p-pi and d-pi interactions.